In short, a chromosome contains all of the genetic traits that make us who we are. Today, we will be looking at 3 traits located on a chromosome for cats. These 3 traits are eye color, coat type, and fur length. So these are chromosomes. Let's say this is parent 1 and parent 2. And our 3 traits, eye color, coat type, and fur length, are located on these parts of the chromosome. This is a genetic map, and this is the distance between these alleles on that chromosome. And this is a distance, 22.1 centimeters between these. Sometimes during meiosis, crossing over of genes allows for recombinant types to be produced. Let's first talk about our NCOs, which is our most frequent form that will happen. Follow the pink line. That individual can either look like blue-eyed, shiny coat with short, green-eyed, dull coat, and long fur. And the chromosomes would look just like the parents, like so. For SCO1, that means that the crossover would happen in region 1. Now because, like I said, 17.9 is shorter than 22.1, the amount of single crossover events at region 1 is less likely to happen than a single crossover event at region 2. But to show you what it looks like, let's follow the blue line. That individual would look like blue eyes, dull coat with long fur, or you would have a gamete showing green eyes, shiny coat, and short fur. And this is what those gametes would look like. See this part switch with this part. Third, let's look at our single crossover at region 2. So this is more likely to happen since this is a longer distance. These individuals would look like, follow the yellow line, blue, shiny, and long versus green, dull, and short. This is what those gametes would look like. See, just this section was what was crossed over. Lastly, let's look at our double crossover, which is our least likely crossover form to happen. Individuals would look like blue, dull, and short versus green, shiny coat, and long coat. For an individual with a double crossover event, only the middle gene was altered. Now we can predict the probability of all of our 8 gametes that will be created by a heterozygous individual. Now I'm just going to show you my calculations for my DCO. You take your R1 value, your R2 value, and your C value shown here, multiply them together, and then you multiply them by 1/2 because you're showing one of the gametes, not both. You just want to look at one of these. If you don't multiply it by 1/2, you'd be looking at the probability of both of these gametes being produced. Let's look at probability of our single crossover. We take our region 1, because it's happening at region 1, and subtract it by our double crossover value. Because we're just looking at a single crossover, that trend could also show this. So we subtract, which is our double crossover, we would subtract the probability of our double crossover just to solely look at our probability of a single crossover happening at region 1. And then we multiply it by 1/2 because we're just looking at this one and not this one. Thank you so much for watching. This is my cat. She has green eyes, short hair, and a shiny coat. She resembles an individual with a single crossover at region 1.